Greetings and welcome to lesson 5.7, Solving Equations by Factoring. For the last several lessons, we were focusing in on factoring polynomials. And you might be wondering, well, why were we putting in all that effort and energy in learning how to factor? Well, here's the answer. We're going to start solving equations by factoring. And well, what type of equations are we going to start to solve? And they're called quadratic equations. So any equation that can be put into the form ax squared plus bx plus c equals 0. And you have to remember that a, b, and c are any real numbers, and a is not 0. B can be 0, c can be 0, but it wouldn't be a quadratic equation if a was 0. It would be a linear equation if a was 0. X squared, or any variable squared, makes it a quadratic equation. If we didn't have this, then we'd have x to the first power, which is linear, not quadratic. All right, so this is standard form. The ax squared plus bx plus c equals 0 is called the standard form. And what we mean is a is just a number, variable squared. The x term is the b term with a variable. The constant term is c with no variable, and it all equals 0. So quadratic term is the one that's being squared. Linear term is the one not being squared but has the variable. And c is just a number, so it's constant. Now, how does this help us solve a quadratic equation when we've gone through all the trouble of that factoring, learning the factoring? Well, it's because we have this zero factor property. So we're just going to say a and b represent any real numbers. If a times b equals 0, then either a is 0, or b is 0, or both of them are 0. Here's why. If a is 0, then you have 0 times any number. Well, that's still 0. If b is the 0, then any number times 0 is 0. And of course, if both of them are 0, 0 times 0 is still 0. That's how we're going to use it with our factors of a polynomial, because we've had a factor and a factor. If this factor equals 0, then it doesn't matter what this one is. It all equals 0. If this factor equals 0, then it doesn't matter what this factor is, it all equals 0. And then, of course, if both of them equal 0, then, of course, 0 times 0 is 0. By factoring it, we're going to set those two things up to 0 and see what the value is that forces it to be 0. That's how we're going to utilize this zero factor property. All right, suppose we want to find the solution for our quadratic equation x squared plus 5x plus 6 equals 0. We're going to factor the left-hand side. So x squared plus 5x plus 6 equals 0. And when we factor, we're looking for two values that multiply to positive 6 but add to a positive 5. Well, the only two I know are 3 and 2. So 3 times 2 is 6, but 3 plus 2 is 5. That will get us, x plus 3 times x plus 2 will get us right back to x squared plus 5x plus 6. Now, using our zero factor property, what that means is either if this first factor is 0, then that makes the whole thing 0, and it makes it true. If the second term is 0, then again, it makes the whole thing true. And of course, if both of them are 0, of course, that's going to make it true. Very rarely will we have something that both of them are 0. So here's what we do. To use the zero factor property, I will break them up and see what is the value for the first factor that forces it to be 0. Likewise, what is the value for the second factor that forces it to be 0. Okay? Now I'm going to pretend that the second equation doesn't even exist, and I have this x plus 3 equals 0, and I'm going to solve for what x equals. Well, subtract 3 from both sides using the addition property of equality, and x equals negative 3. Okay, so I've solved the first equation. Now the second equation, x plus 2 equals 0. Let's subtract 2 from both sides. X equals negative 2. These are my solutions to this equation. So I'm going to check it just to make sure. Now, in the original equation, when x equals negative 3, because that's what I said one of my solutions was, I get negative 3 squared plus 5 times negative 3 plus 6. Does that equal 0? Scooch up, give me some room. Negative 3 squared is 9. 5 times negative 3 is negative 15 plus 6. Does that equal 0? 9 minus 15 is negative 6 plus 6. And negative 6 plus 6 is indeed 0, and 0 equals 0. So x equals negative 3 is one of my solutions. Now I just want to double check. When x is negative 2, let's see what happens. Well, negative 2 squared plus 5 times negative 2 plus 6, does that equal 0? Negative 2 squared is 4, and negative 5 times negative 2 is negative 10 plus 6. 4 minus 10 is negative 6 plus 6. And of course, negative 6 plus 6 is 0. And 0 equals 0. Therefore, both of my solutions work. Now, I do want to just bring this all together and create my solution set. My solution set is in brackets, and it's negative 3, comma, negative 2. These are all the values for x that makes my equation true. And my equation was x squared plus 5x plus 6 equals 0. In fact, these are the only two real numbers that do make this statement true. So how do we go about solving quadratic equations by factoring? The first step is to put an equation in standard form. That is, the ax squared plus bx plus c equals 0. Then we're going to factor our quadratic equation completely. We're going to use our zero factor property to set each factor to 0. We'll solve those individual problems, and then we'll check our solutions. So let's try an example. 2x squared minus 5x equals 12. First and foremost, it is not in standard form. My first job is to move everything to the left-hand side, leaving 0 on the right-hand side. So let's subtract 12 from both sides using the addition property of equality. My new equation is 2x squared minus 5x minus 12 equals 0. That was our first step. We have now put it in standard form. Next step, we're going to factor completely using our factoring strategies. 1, look for a GCF. 2, if it is a binomial, then we can look to see if it is the sum of squares, difference of squares, sum of cubes, difference of cubes. If it is a trinomial, then we're either going to see if it is a perfect square, or we can also see if we can do this in trial and error or that X method. This is a trinomial, 1, 2, 3 terms. So first things first, I'm going to see if there's GCF. Doesn't look like there is. I have 2, 5, and 12. There's nothing in common there. So my next move is to see if it is a perfect square. 2 is not a perfect square, 12 is not a perfect square, so that's out. Third step, I can use trial and error, which means I break down 2 into its prime components. I break down 12 into all of its components and see what special combination makes that true. I think that's too much work for this problem, so I'm going to use the X method. And the X method, what I do is I take the first term, 2, and I multiply it by the third term, and this is just the numbers, negative 12, and I come up with negative 24. In this bottom little portion of the X, I put the number that's in the middle, negative 5. I'm looking for two numbers that multiply to negative 24, but add to a negative 5. Because I'm multiplying to a negative number, one number's got to be negative, one number's got to be positive, and because they add to a negative number, I know my larger number is negative. So I have a negative on this side, a positive on that side, and now I have to find the numbers. 24 could be 1 and 24, could be 2 and 12, but neither one of those do the trick. I think I'm going to jump to 8 and 3. If I have an 8, a negative 8, and a positive 3, they do multiply to negative 24, and negative 8 plus 3 is negative 5. So I found my special combination, and what do I do with it now that I found it? I rewrite the middle term using these numbers. 2x squared minus 8x plus 3x minus 12 equals 0. And you might be saying, hey, you just made it worse. No, I didn't, because now I could break this problem, this big problem, apart into smaller problems. And I can factor each one of those little groups and see if, from factoring those groups, to see if there's anything in common. Okay, so for the first group, looks like its greatest common factor is 2x. And if I pull out a 2x, I am left with x minus 4. And just to double check, 2x times x is 2x squared. 2x times negative 4 is negative 8x. Perfect. I can get right back to where I started from. Plus, now just looking at the 3x minus 12, it looks like the GCF is 3. So if I pull out a positive 3, I am left with x minus 4. And again, just to double check, 3 times x is 3x, and 3 times negative 4 is negative 12. I can go right back to where I came from, so I'm good. All right. Looking at my new problem, they both have the x plus 4 in common. So I'm going to factor that out. All right. X minus 4, and I said plus 4, sorry about that, minus 4. That leaves behind a 2x plus 3. And all of that equals 0. Now I'm completely factored, and I can move on to step number 3. So that's step number 2, completely factor it. Step number 3 is using the zero factor property and set each of the factors to 0. So x minus 4 equals 0, and 2x plus 3 equals 0. I'm going to scooch up so we have a little bit more room here. I'm going to solve each of these problems individually, like the other one just didn't exist. Okay, so looking at x minus 4 equals 0, we're going to add 4 to both sides, and we have x equals 4. I found one of my possible solutions. I still have to check to make sure that I did all my math correct, or correctly, but it's great that I did find x equaling something. I just got to check it. Next one, I'm going to solve for x here. Minus 3 from both sides. That leaves 2x equals negative 3. I don't want to know what two x's are, So let's divide by 2 to undo that multiplication. And I have x equals negative 3/2. I found my 2 possible solutions. That was step 3. So my 2 possible solutions, are negative 3/2 and 4. Now our 4th step is we do need to check it. I know there's a fraction, but let's not worry about the fraction too much. It's not that bad of a fraction, luckily. But I'm going to plug these into the original problem. So when x equals negative 3/2, we have negative 3/2 squared. I don't want to forget that multiplication of 2 out front. Minus 5 times negative 3/2. Does that equal 12? Remember, the original equation had the 12 on the right-hand side. So I just want to make sure, does this left-hand side, will it equal 12? If it does equal 12, we found one of our solutions. Okay. 2 times, well, negative 3/2 squared is negative 3 times negative 3 is 9, and 2 times 2 is 4. And I'm going to go ahead and write out the rest of the problem here. Okay. Now I got to do some multiplication, got to follow order of operations. So 2 times 9 is 18, but I think I am going to reduce first. 2 goes into 2 once, 2 goes into 4 twice. So I have 9/2, and negative 5 times negative 3 is positive 15/2. And luckily we have the same denominator, so all we need to do is add the numerators. And 9 plus 15 is, what is that? 24/2. And 24/2 is 12. We found one of our solutions. Perfect. Now, that was only one we checked. When x equals 4, let's see what happens. We have 2 times 4 squared minus 5 times 4. Does that equal 12? 4 times 2 is 16 times 2 minus 5 times 4. 2 times 16 is 32 minus 5 times 4 is 20. And 32 minus 20 is 12. And 12 does equal 12. We found our 2 solutions. So our 2 solutions indeed are the correct solutions to our equation. All right, so let's try another problem, but this time I'm not going to focus on the factoring because you should have that down by now. I'm going to focus on using the zero factor property. Okay, so because this is a binomial, the first thing that pops into mind is it the sum of squares, difference of squares, sum of cubes, difference of cubes? Well, the first a is squared, so it's not the difference of cubes or sum of cubes. And it is the difference, so I just have to check to see if these numbers are perfect squares. 16 is a perfect square, 5 is a perfect square. Oh, equals 0. Therefore, I can rewrite this as 4a quantity squared minus 5 squared. And because I've now written it in this format, it is the difference of squares, and we have a nice formula we get to use. One's addition, one's subtraction, first term's base, second term's base, second term's base, and unfactored. Yay, we love our formulas that we can quickly fill in the blanks. Now, I'm going to break this problem apart into smaller problems to solve this big thing. The first one I want to do is 4a plus 5 equals 0. This is our zero factor property. And 4a minus 5 equals 0. I'm going to solve these problems individually. I'm not going to worry about that second one. I'm going to focus on the first one now. subtract 5, and I get 4a equals negative 5. Divide by 4, and therefore a possible solution is a equals negative 5/4. Yes, I know it's a fraction. Don't get freaked out about fractions. Sometimes they're not bad to work with. Okay, now that I've found a possible solution for the first equation, let's worry about the second equation. Add 5 to both sides. So I have 4a equals 5. Divide by 4. And our second possible solution is a equals 5/4. Okay, so now we have to check these. I get when a equals negative 5/4, it's going to be 16 times negative 5/4 squared minus 25. Does that equal 0? Question mark up there. Okay. Negative 5/4 squared is 25 over 16 minus 25. I'm going to reduce now. 16 goes into 16 once. 16 goes into 16 once. That leaves 25 minus 25. And 25 minus 25 is 0. That is one of our solutions. Okay, that was one. When a equals positive 5/4, not much of anything really changes here, but we want to work it out just to make sure. 16 times 5/4 squared minus 25, does that equal 0? Well, positive 5/4 squared is 25/16 minus 25. Again, I'm going to reduce. 16 goes into 16 once, 16 goes into 16 once, leaving 25 minus 25. And 25 minus 25 is indeed what we're trying to find, 0. Now you may be asking, why was it exactly the same? Well, it wasn't. The signs were different, but because we were squaring it, a negative times a negative is a positive, and a positive times a positive was a positive. Therefore, after that very first step, the process ended up being the same. And if you recognize the process is the same, you can kind of stop there and say, yep, it all works out, because in essence, from this point, it just follows the same path. Okay, so our solution set for this problem, a can equal negative 5/4 or positive 5/4. And that's it. The hard part, I think, was learning how to factor this. Once you've factored them and set them all equal to, you just have to make sure that your equation is set to 0 first, and then you factor the left-hand side. Solving those equations for 0 has been something that we've been doing for months and months and months. So that's it for this video. Until next time, be seeing you.